Lesson 3. Hypothesis testing for zero correlation. You can use a hypothesis test to see if the product moment correlation coefficient, R, for a specific sample indicates that a linear relationship is likely within the entire population. For a sample, we use the letter R to denote the PMCC. For the entire population, however, it's denoted as the Greek letter rho. To test for a specific correlation, i.e. if rho is greater than 0 for a positive correlation, or rho is less than 0 for a negative correlation, use a one-tailed test. Either your null hypothesis is that rho is 0 and your alternative hypothesis is that rho is greater than 0, or your null hypothesis is rho is 0 and your alternative hypothesis is that rho is less than 0. To test for any correlation, i.e. where the coefficient is not equal to 0, you need to use the two-tailed test, where h0 will be rho is equal to 0 and h1 will be rho is not equal to 0. You can find the critical region for the hypothesis test by using the table of critical values in the formula booklet in your exam. The critical region depends on the sample size and the significance level. For example, a sample size of 6 at the 5% significance level has a critical value of 0.7293. If testing that rho is bigger than 0, you reject h0 if your value of r is bigger than this number, 0.7293, as the positive correlation is greater. If testing that rho is less than 0, you reject h0 if your r is less than minus 0.7293, as there's a greater negative correlation. Let's do one example. A scientist takes 30 observations of the masses of two reactants in an experiment. She calculates the product moment correlation coefficient, R, to be equal to minus 0.45. The scientist believes there is a correlation between the two masses. Test at the 10% significance level if the scientist's claim is correct, stating your hypothesis clearly. We're testing if there is any correlation at all. So our H0 is going to be rho is equal to 0, and our H1 is going to be rho is not equal to 0. Our sample size was given in the question and is equal to 30. We're testing at the 10%, but this is for both tails. So each tail is going to have a 5% significance level. The critical values from the table are R is equal to plus minus 0.3061. So the critical region is when R is greater than 0.3061 or R is less than minus 0.3061. And the value we already have from the question, minus 0.45, is less than minus 0.3061. So the observed value of R falls within the critical region. And therefore, we reject H0, as there is significant evidence at the 10% significance level that there is a correlation between the masses of the two reactants. And that's about it.